Okay, so this is integration of exponential functions. Okay, so what makes something exponential? Not just that it has an exponent. Yeah, it has to have variables in the exponent. So if we look at the first three, we can see that we have something, which is your a, to the, and your power has an x in it. So if you look at the rule, your u is the power. So we're still doing u sub, and your u is going to be your power. Now, to be able to do this rule, which we'll get to in a second, I have to have my u prime or my du, same thing. So a to the u du. So if I look at number 1, what are you going to let your u be? Yeah, your u is your power. So I'm going to let my u be my x. So what is du? 1 dx. Do you have all of that? Or do you need to balance it? Do you need to make something? I have to have a to the u du. No, 2 is the a. Okay, so here's what I have. I have 2 to the u du. I just replaced my, y'all told me to let the u be the x, so I replaced it. My du is 1 dx, which I have. So I have 2 to the u du. I've done no calculus yet. It is that step, yes. Okay, now the rule says when I integrate this, I have my plane a to the u. So who is that in this problem? 2 to the u. And then he's going to be over ln of what? Two things we're forgetting. Plus c. And I can't have it in terms of u. So I have to put my what u equals back in place of u. So to quit saying 2x. Thank you. 2 to the x over ln of 2. Yeah, that's not 2x. Okay, let's try another one. So number 2 is an exponential function. So what are you going to let your u be? Good. So what is du? What is the derivative of x? Okay. Do you have everything? So I have the integral of 5 to the u du. So a is a number, and that is part of my integral. The u sub is just for the power.
So it's not like 5x. It's like 5.
It is.
5x is different.
Correct. Yes. Okay, so then what's the rule? Like, integrate it, do your calculus. Not 5u. 5 to the u over ln of 5 plus c. Now put your u back in there. Okay, so that is as simple as they will ever get. So now look at number 3. We're adding a little bit of meat to the power. Okay? So what is your u? So what is your du? Now, notice that this 2 right here is a staple, like he's part of the problem. I don't need to account for him. I do need a 3, which I don't have, like a plain big boy 3, not a power 3, like a regular 3. So I'm going to balance it with a 1/3. So 1/3 integral of what? 2 to the u du. Because remember, we put a 3 in here and we put a 1/3 out here. Everybody okay? So now, integrate it. 2 to the u over 3 ln of 2 plus c. Plug your u back in. Now there is something that you have to be careful about. Because with logs, see that 3 that's in front of the log? How else could they write that? What are numbers that are out front of logs? So this could be 2 to 3x over ln of what? Yep. And they could do that and not tell you that they're going to do that, but if you go answer shopping and you see an ln of 8, it's going to throw you off because you're looking for an ln of 2. So don't answer shop. Okay. Now watch this. There's something else they could do with this answer. Y'all see this? That could be this. Where'd that 8 come from? 2 cubed. So 2 to the 3x is the same thing as 8 to the x, because 2 cubed is 8. So they could do this. So if it's an FRQ, I'll take that one. But if it's multiple choice, just know that they could go any level of that they want to. Oh, yeah. On the homework, what you're going to see on my homework is you're going to see lots of this. Am I going to do that on your test review and your test that's multiple choice? Yes. I'm going to go here for some. Not all, because I want you to be flexible. Yeah. You're welcome. Okay, now number 4 has an X down here on the main level. So why? What is his job? What's the role he's supposed to play? This is an exponential function.
Because when you take the derivative of that exponent, you'll already have the x.
Which you need, right? Aren't you going to need that x for the derivative of your u? And remember, you can't fabricate an x. So that's why you've got to be able to start looking kind of down the road. If I let my u be my power, then my du is going to be negative 2x dx. And I have the x and the dx. I need a negative 2, so I'm going to balance it with a, so negative 1/2 integral of 3 to the u du. So then that's going to give me what?
3 to the u, negative 3 to the u over ln of 2 ln of 3.
Plus c.
Oh, yeah.
And then put your u back in here. Now, what could they do to this guy? Think about it. What do negative exponents? Ignore this negative. What do negative exponents do? Right? And they can totally do that. It's like twisting the knife just a little bit. Okay. Oh, Trig. Here we go. What's your U? Okay, now think about which way you're going.
Negative.
Which way are you going? Are you going that way? This is a regular derivative. So it's what you're taking the derivative of, and R starts with an S, so no negative. So I have the integral of. Yeah, that's it. Do you need anything? No, I have everything I need. So this one's straightforward. So what are you going to have? 2 what? Over ln of 2. You can't do anything to him. I can't judge him up anything.
So we have to know these formulas, but they're not like you're not gonna.
I'm not going to give them to you. Because they don't give them to you. So yes, you have to know all of them. Which is why I think having that extra day of review is going to be helpful. Because Wednesday's going to be the first day where we throw everything together, and you've got to like.
We're gonna be like.
U's got to be something. I don't know what it's got to be, but it's got to be something. Okay. How are these different? These are E's. So the rule is exactly the same. But what's 1 over ln of E? So this piece right here is still part of my rule, but this goes to 1. So it really ends up just being that. Do y'all see it? So what's your U? What's your DU? Okay, so what do I need? I need a 1/5 integral of. So what do we got?
Is that every time?
Every E. Now, what you have to be careful about is when you get used to E's and you go back to something that's not an E, remembering that part. It is. It's a lot like when you take the derivative. It's the opposite. Okay. So tell you what, you try number 2. I'm going to give you a 20-second head start. Perfectly said. These are not difficult. You just have to know your formulas. And you have to be comfortable enough. Now, every time you see an exponential function, your u is not your power. So, and you dive into a little bit of that on your homework. I'm going to throw some curveballs to you on your homework. I know, get excited. Okay, so when I look at number 3, now obviously you know what to do because we're in the middle of learning this skill, but look at this. Can you see you don't have a product rule? You have a 5 and an x and an e to the negative x squared. What should your u be? So what of that extra stuff out front do you need? I need the x. What's the 5? Extra. So he's just going to kick out front. So my u is going to be a negative x squared. My du is, so I need a negative and a 2, and I have an extra 5.
So a negative 5 over 2.
Yeah, so I'm going to have a negative 5 over 2. The 5 is extra, and the negative 1/2 is what I needed to balance it. And then that's e to the u du. So negative 5 over 2, e to the plus c. But I want you to keep in the back of your mind that technically this is over the ln of e, which just happens to be 1. So you don't get out of the habit when it's not an e. Okay, so try 4 and maybe 5. How are we on 4? Everybody okay on 4? So for 5, what do I need? So how do I balance that?
You could leave it like x over 3 over 2, right?
Yeah, totally. Yeah. It just helps me when I'm doing derivatives to see the number separate when I'm going from u to du. Okay. You need to be super, super comfortable when you look at number 6 and you see that x squared on the bottom, that's really just x to the negative 2. Everybody comfortable with that? Okay, and when you see your e to the 1 over x, that's e to the x to the negative 1. Y'all okay with that? So I'm not going to let my u be 1 over x because I'm not going into this thinking it's a quotient rule, like a low D high. I'm going to go in here thinking that my u is e, nope, not e, that my u is x to the negative 1.
Can we like rewrite it or do we need to?
Totally, you can totally rewrite it. So yeah, you could start off and rewrite this as e x to the negative 1 times x to the negative 2 dx. Totally fine. So what's my du? So I have him. I just need a negative. Now, how else could they write that answer? Mm-hmm. Everybody okay? And that multiple choice answer would be riddled with negatives and positive and e's to the x to the negatives and positives and 1/overs, and you've just got to be really clear on your algebra rules there. All right, number 7. What you gonna let your u be? Do y'all see that? I mean, do y'all notice the e kind of smushed in there? That's what your focus has got to be. So u's going to be cosine of x. Okay. Good. Negative sine x dx. So I need negative e to the cosine x. Okay. U? Du? So don't need a thing? Okay. Now, help me with the thought process on number 9. That is a cotangent up yonder. So if I let my u be cotangent.
Sine on the bottom is a cosecant.
It is. What is the derivative of cotangent? Cotangent isn't the one that wants himself in its derivative. That starts with a C. Negative. There it is. And so if his derivative is a negative cosecant squared, a sine squared on the bottom is a cosecant squared on the top. Do y'all see that?
When you do that, when you like something on the bottom is the same thing as on the top, do you change your power to a negative?
No. No, because 1/sine is cosecant. Like,
yeah, I know.
1/sine is sine to the negative 1. Does that make sense? So I'm going to rewrite him just so we're crystal clear. I'm going to rewrite him as e to the cotangent x times cosecant squared x dx. Because I know that cotangent and cosecant squared are linked with derivatives. So my u is cotangent x. My du is negative cosecant squared x dx, which I have. I just need a what? A negative. So negative e to the u du. So negative e to the cotangent x plus c. Okay, so here's a question. Was that difficult? No, but filing this in with all the other derivatives and u subs and all that other stuff swimming around in your head, It just adds another layer. It just adds another layer. Good times. Okay, so if I'm looking at your homework for this one, yeah, that's your homework for this first part. Okay, so guys, look, 1 through 10, super straightforward, easy peasy. Number 11 and number 12, I'll give you a hint. Number 13 through 20. Okay, here's your hint for 13 through 20. U doesn't always have to be the exponent. Don't forget all the other rules you know. Because look at number 13. If you let your U be an X, what's your DX? Or what's your DU? If you let your U be X. Okay. So if you let your U be X, think about what number 13 would be. That would be e to the u times e to the u plus 1 squared. Do you see how that does not fit this rule? So let your u be the meat. So what's the meat of number 13? E to the x plus 1. So your u is e to the x plus 1. What's your derivative of that? Derivative, not integral. E to the x, which you have out front. So what would number 13 break down to once you put your u sub in? U squared du. Your u is e to the x plus 1. So u squared du, so now you're 1/3 u to the 3 plus c, and then plug your u back in. That doesn't use this rule you just learned at all. All my work is posted. Everything is there. Okay? But that bottom section, just be careful on that bottom section. Okay, so now we're flipping to this guy. So you have 3 more to memorize, technically. But I will say this. There are 6. This is inverse trig. Do y'all see why this is called inverse trig? Do y'all see the sign of the negative one? That's the inverse part. So this is a sine, a tangent, and a secant. There are these for the other 3 trig functions, but you don't ever see them. And in fact, for brain space sake, this guy is going to show up, but he's not important enough to memorize. Okay? If he pops up on a multiple choice, we're just going to take an L for that. It's not worth the brain space. I promise, it's not worth the brain space. You need to focus on those 2. Trust me. You need to know sine inverse, and you need to know tangent inverse. Okay, so let's focus right now on this side so that you can recognize which one's a sine inverse and which one's a tangent inverse. Okay, so tell me, obvious, what does sine have that tangent doesn't? It has a root on the bottom. So if I'm looking at number 1 and number 2, what do they have to be? Those are sines. Okay, now sine has a squared minus u squared. Well, guys, a squared is a number. So it's going to be like 4 or 25 or 7. And that's your a squared. So here my a squared is 1, and here my a squared is 9. Then it has to have a minus. What does tangent have? So sine has a root and a minus. Tangent has no root and a plus. So tangent is like crazy mainstream. It's got a plus sign. There's no root there. Sine has 2 things that are weird. He has a root and he has a minus. Now u squared means I'm going to have a variable in it. So this is my u squared. And this guy over here is my u squared. And so I need to know who a squared and u squared are because I need to know who a is and who u is, because they wind up in my of. So it's sine inverse of u over a and tangent inverse of u over a. Now, who is u? Is u the one with the variable or is u the number? He's the variable. So it's variable over constant. Variable over your constant. Variable over your constant. Now, what does tangent inverse have that sine does not? So think about it this way. Sine has this extra root and this extra minus that tangent does not have. But when it kicks out the answer, tangent has this extra 1 over a in front of it. So really your job is to find a and u and then to use the formula. Now we haven't talked about what's on top. What's up here? The derivative of your u, so that you may have to be doing some balancing there. Okay, so let's start with trying to identify what u squared is and what a squared is. Okay, so what's a squared? So what's a? Okay, what's u squared? So what's u? So what's du? Do y'all see what I just did?
So we're going to have 4 now instead of just 2.
Well, a lot of people don't write this part down. They'll just say, oh, well, if that's a squared, then my a is a 1. And if that's u squared, then my u is an x squared.
For your answer, you don't need a.
Right.
Okay.
Yeah, I'm not interested in who a squared, r, and u squared is. I need a and u. I'm just acknowledging the a squared and the u squared to get to the a and the u. Okay, so talk to me about my du. I need a 2. So guys, I'm just going to come in here and put my 2 and put my 1/2 out front. So now, does it fit this? Okay, so we are, now I have this extra 1/2 because I had to balance. Sine inverse of my 1/2 is from here. X squared over 1, which is just x squared, plus c. Done. Okay, so now I want you to try 2. Questions? We okay? You're tapping your foot, your shoelace was. Okay. Now, number 3, I do not see a root. So what are we thinking? Tangent. It's still the a squared and the u squared, all that's the same. So who's your a squared? Who's your u squared? So who's your a? Who's your u? And who's your du? So don't need a thing. Don't need a thing. Now, tangent doesn't have the extra stuff in his integral, but he does have a little extra stuff in his answer. He has this 1 over a part out front. So we're going to have a 1/2. Not because I had to balance anything, but because that's part of his result. You would multiply. So do not answer shop. Because if you answer shop, you could have a number, a fraction out front because it was balanced, or a fraction out front because it's the tangent rule. So don't shop. Tangent inverse of u over a. Plus c. Okay. 4 has the root and a minus. So what are we thinking? Sine inverse. So what's your a squared? And your u squared? So your a is, and your u is, and your du is. So I don't need a thing. And this is now sine. So sine inverse of, yeah, x over 2 plus c. What? Oh no. Oh God, it's a 7. Okay. I see no root and no minus, so what are we thinking? Yeah, we're thinking this guy. So, what is my a squared? 7. What is my u squared? X squared. So what is my a? Good. And what is my u? And what is my du? Okay. You good? So I am 1 over a, so 1 over root 7 tangent inverse plus c. All right, 6 has, I mean, it looks like it has a lot. So here's the question. Would you be able to pick this out? Would you know amongst all the integration that when you get to this one, you're going to say, oh, that's that inverse trig thing. Okay, so here's how you eyeball it. All your squared crap is on the bottom, and it has to be 2 terms on the bottom. Y'all agree with that? Like, it has to be separate. And he has a little extra something out there. Okay, so when I see 2 terms, okay, so let's say you did not do this one with this, and let's say you did u sub, and you let u be this. What's your du? Can you fabricate that? You see how you can't? I can get the 2, but I cannot fabricate an x. So u sub would not work there. And they're going to sneak that in with a 7 because it's more obvious when I have a 4 and a 4 or a 9 or a 16 or something squared. But when they slip in a 7 that's not super obvious a square, it throws you off. But guys, please don't panic when you go down this road and you're like, oh my God, this problem is broken. No, it's not. It just means you need to take another avenue. And that's why when we throw all this integration together on Wednesday, you need to focus on which avenue to take and knowing all your avenues. And so we're going to make like a bag of tricks like we did in pre-cal. We're going to make a bag of tricks so you kind of have what avenues you can take. Okay, looking at number 6. I see the root, I see the crap underneath. So what's A? Oh, sorry, A squared. What's U squared? So what's A? So what's U? Okay, now what's du? What is the derivative of tangent? Which I have sitting on top. Right?
I was looking at the extra x, but
That's your of. Secant squared of x. And we're saying this one's sine. So sine inverse of now how's that for some fun math? You have trig of trig. Okay. Who does this kind of sort of look like?
it's giving me secant vibes. Is there something that?
Secant has a root and a negative. Tangent doesn't have somebody sitting out front. Now this x that's out front could be thought of like this. So kick him up. So if you let your, let's see, if we did this and we said a squared is 1, u squared is ln of x. So what's your a? What's your u? It would have to be this.
Squared be ln of x squared because there's a square.
Yes.
And then u would be ln.
Yeah, what is the derivative of ln of x? Dov over of, so 1 over x. Which is him. So are we fitting that guy? So 1 over 1 out front. Then tangent inverse of your a. I'm just following the formula. 1 over 1. So tangent inverse of ln of x over 1, right? So just ln of x. Now look at that. That's inverse trig of a log function. Good stuff. Okay, so try 8. What's your u? Good. Okay. How do you take the derivative of e to the x? Leave it. Derivative of the of. Good. So e to the x times 1 dx. And do I have that? Okay. So tangent inverse of e to the x. Everybody okay? Thinking tangent again? What's your e to the 3x? Because if I were to take that and square it, power to a power you multiply. And that's where the 6 comes from. Okay, so what's your du? Good. Dx. And I need something. I need a 1/3. Now the 1/3, that's not a part of any sort of formula, that's me balancing. What is the part of the formula? Right, which is 1 over 1. Now if that was like a 2, if your a was a 2, then this out front would become a what? 1/6. Right, you multiply. So there's my 1/3 from balancing, and then I'm multiplying it by 1 over 1 from the formula. And then tangent inverse Okay, so again, where have most of our problems been focused? Tangent for sure, and then some sine. We haven't touched a secant, and that's how you're going to see in the problems. Lots of love given to tangent, a little bit of love given to sine, very little, if any, at all given to secant, which is why we're not going to worry about memorizing him. Okay? But number 10 is... Now, look at what else is different about number 10, about secant. Who comes first? The u comes first. So do y'all see how this can't be my a? A has to be a number. U is your variable. So he couldn't be an a if he wanted to. But that's good because secant has the u squared first. So my u squared is x squared. My a squared is pi. So what's my u? And what's my a? And so what's my du? 1 dx. Okay, now hold on. Who is that? Because I don't need him for my du. He is a part of the formula. He has to be here because the formula says so. And that is my u. He doesn't do anything. He has to be there. If he's not there, you're not secant. So I'm 1 over, I'm following my formula. No. 1 over root pi. Secant inverse. X over root pi. Everybody breathe. Everybody take a deep breath. These hide in plain sight. You're doing your test review or you're taking your test and you're like, oh, I'm going to let you be all this and my du. And then I'm going to, what? Nothing. You can't do anything. So you have just hit a brick wall, which means erase and find another road to take. Do y'all see? Do you see what I'm talking about? Like you're going to go and you do not have time to panic. You have to know that you have other tools. Now, do you agree with me that everything in the denominators of these suckers is squared? You know how to make things squared. It's one of my favorite all-time things to do. I tortured you heavily with it in pre-cal. There's a grandpa. Complete the square. Mm-hmm. Who what?
11 and 12. Okay, I'm going to go ahead and write.
Mm-hmm. Like, look at my notes. I have this big pink line going across. I was like, these two are different. Okay. You are going to complete the square in the denominator of an integral. Slide, Grandpa. Half it and square it. Mm-hmm. So plus 4, but then you turn around and that's what keeps it legal, because technically you didn't add anything. No equals. There's no equals in any of this. We're not solving anything.
When is the thing where you set it equal to 0?
You don't set it equal to 0. It has an equals already in it. Like if you're doing an ellipse or hyperbola and you're getting it into form, there's an equals already there. Okay. So now this turns into what? So x plus 2 squared plus 1. Does that make sense? Do y'all don't remember? We would always say this sign is always the one that comes down, and the square to him is always the number that goes right there.
So what is the 4 and the 5 do?
Well, the minus 4 is what allows me to do this. Like you can't just go in there and say, I'm gonna add 4. You can't do that. But I can plus 4 and minus 4 because really I did nothing.
So then you stack to that part and whatever side that outside.
Mm-hmm. So now, be careful. What's your a squared? Your a has to be your constant. Your u is your variable. So guys, this part is my u squared. And this guy is my a squared. That looks like a fraction. A squared equals 1. Okay, so let's do this. I didn't think I had to do this, but let's do this. Y'all watch what I'm going to do. What did I just do? I just flipped them. Because y'all are having trouble seeing who the a squared is and who the u squared is. So guys, the a squared, it does not necessarily have to be the dude in the front, especially when they're both pluses, which is tangent. Everybody's positive on the bottom. So your a squared is the constant. Your u squared is the dude that has the variable in it. So what is A? What is U? What is your du? So let's see, I'm tangent 1 over A. So 1 tangent inverse of U over A. Now, do you have to have that of in parentheses? Yes, it's multi-termed. If you don't put it in parentheses, that's tangent inverse of X, pause, plus 2. Bless you, man. Bless you. Now, number 12 has a root. So who are we thinking? He's leaning towards a sign. We also have this negative in the bottom, but doesn't that make sense? Like, shouldn't we expect that? Okay. But we have to be able to algebraically deal with him correctly.
So we're about to complete a square in the integral in the denominator under a root.
Under a root. And we're going to have to GCF a negative.
GCF!
But remember, you don't touch grandpa. So I'm just going to GCF the negative out of the x's. Remember how we don't touch grandpa because it makes him confused? What's half of 4? Square it. So I'm going to put a plus 4. But guys, when you put a plus 4, what did you really do? You really minus the 4. So I'll come over here and add 4. Yes. Because when I wrote plus 4, the value was really a minus 4. Okay, what do we got? No. I want parentheses. X minus 2 squared plus 1. Okay, now this kind of blew your mind on the last problem, so I'm going to flip him, okay? Y'all watch. Y'all okay with that? And flip him, don't flip him, it's whatever you're comfortable with. But you cannot mix up your A and your U. So who is A? Sorry, squared. So A is 1. Who is your U squared? So who's your U? And who is your DU? Okay. And this is a sine, correct? Sine has nothing out front. So sine inverse of U over A. Where'd you get an X squared?
X minus.
Okay. Okay. Plus C. Yeah, he's here. And he has to be there because of that. Y'all good?